the defense of Liva Abele. My name is Ninette Pilegaard. I'm senior researcher here at DTU Management Engineering, and I will be the moderator of today's defense. First, I would like to welcome the committee, the evaluation committee, Professor Andres Verheili, Department of Technology and Society from Lund University in Sweden, Associate Professor Niels Agerholm, Division of Transportation Engineering, Aalborg University, and Associate Professor Michael Brun-Barfod, DTU Management Engineering, and Chairman of the committee. I would, of course, also like to welcome the PhD candidate Liva Abele and her supervisors, Senior Researcher Mette Müller and Senior Researcher Sonja Haustein. And of course, also a welcome to the rest of the audience. Today we will start with a presentation by Liva of approximately 45 minutes. Liva will, in her presentation, summarize her PhD thesis that's titled Young Drivers' Hazard Perception Skills in Pedestrian-related Situations. The work is within traffic safety and has been carried out at the Department of Management Engineering at DTU under supervision of Mette and Sonja. As mentioned, the talk will be approximately 45 minutes. If Liva exceeds this limit, I will have to interfere, give you a notice, and allow you a short conclusion. After the presentation, there will be a short break, approximately 10 minutes. And if some in the audience do not intend to stay for the questions afterwards, then they can leave during the break. After the break, the assessment committee will be given time to ask questions to the thesis and the candidate. And then, when the committee is done asking questions, the supervisors have the opportunity to ask questions. And finally, if anybody in the audience would like to ask questions, they will have the opportunity in the end. However, if you wish to ask questions, please notify me during the break. The total length of the defense will be maximum 3 hours. So we will end at 4 o'clock at the latest. After the defense, there will be a reception in building 372, room 221. And after the defense ends here, the committee will go and decide on whether to accept the defense. And then they will go to the reception and announce the results. So now we are ready to begin, and Liva, I leave the floor to you.
Yeah, thank you, Ninette, for introduction. And hello, welcome everyone to my PhD thesis presentation with the title of Young Drivers' Hazard Perception Skills in Pedestrian-related Situations. Let's start off with some background. In recent decades, road safety has been remarkably improved, and fewer people are getting killed or injured on the roads. However, pedestrian fatalities account for more than 1/5 of overall number of the deaths on the road. And pedestrian accident rates are decreasing less compared to the driver accident rates. So the pedestrian accident injuries continues to be a serious road safety problem. Children and elderly pedestrians account for the highest share of the pedestrians killed of the pedestrian fatalities, and children, 1 in 5 killed in the roads, were actually pedestrians. When looking at pedestrian-related accidents, the recent research focuses on the behavior and skills of the children, but due to the limited cognitive and motoric skills of the pedestrians, the knowledge about drivers' behavior in relation to the pedestrians is highly valuable. And several factors have been identified to significantly change the probability and severity in a car-pedestrian accidents. And these are pedestrian, driver, environment, and also vehicle-related. And some of the factors, like a lower driver's age, are associated with a higher risk in fatalities for the pedestrians. So if there is a car-pedestrian accident, which is caused by a younger driver, there's higher chance that it's going to lead to the severe accident. So the young drivers, they still remain to be to face the highest fatality and injury risks in a traffic. And so there are two main categories of the factors that influencing the young driver's involvement in accidents, which is driving style and driving skills. And the skill gap between the experienced and younger drivers is the main factor behind the overrepresentation of young drivers in accident statistics. And one of the main issues for the young drivers is their lack of hazard perception skills. With hazard perception skills, we understand drivers' ability to detect, evaluate, and respond to potentially dangerous situation, which might develop further to actual hazard, leading to an accident. In my project, I concentrated looking at the two abilities, namely hazard fixation, which is hazard detection, and also the visual attention to the hazard during all the hazard period. And also the hazard response, which is deliberate reaction to the hazard by decreasing the speed or moving further away the hazard while approaching it. And these two abilities have been shown to discriminate between more experienced drivers and less experienced drivers. And they also can be objectively measured, for example, using a driving simulator and a night tracker. There is extensive research which shows that young drivers lack the hazard perception skills when compared to more experienced drivers. And some of the factors for that is that young drivers, they haven't had experience to see the wide variety of the situations and hazards. And also they tend to overestimate their driving skills. So they are more willing to be involved in high-risky situations. And also that there are limitations in their training, so that there's not enough focus on developing the higher order skills such as hazard perception in their training. Based on the fact that there are still a high number of the pedestrian accidents and limited hazard perception among young drivers, the main objective of this project was to contribute to the safety of the young drivers and pedestrians by identifying the ways to improve the young drivers' hazard perception skills in pedestrian-related situations. So the project itself consists of two experimental studies. And in the first study, I looked at the hazard perception skills among the young drivers in a driving simulator to increase the knowledge of the pedestrian-related situations from the driver's perspective. And the results of this study are presented in 3 papers. 2 of them are in press, and 1 is in a conference proceedings. And for the second study, I tried to improve the hazard perception of the young drivers in a pedestrian-related situations. And the results are presented in 1 paper. So let's move to the first study. I'm just going to take a sip. So the aim of the first study was defined to be to examine differences between the groups within the young drivers with a higher hazard perception skills and lower hazard perception skills, detected in a driving simulator, measured by the hazard response, focusing specifically on the visual behavior of the drivers in different hazard situations of a different variety of the difficulty and with different types of pedestrians, and also to see how young drivers assess their hazard perception skills and how in line it is with the objectively measured hazard perception skills in the driving simulator. The study was done with the 65 young drivers, where they were exposed in a driving simulator to situations, visible and hidden situations, with adult and child pedestrians. So what all this means? It means that situations were potential. Potential means that they could develop further to actual hazards, but they never did. So when the driver was approaching the pedestrian, which was looking at the ball and starting to cross the street, but stopped after 2 meters. They see the pedestrian, and they have to read the behavioral cues of the pedestrian. However, in the hidden hazard, the pedestrian was obstructed, they couldn't see it, so they had to read environmental cues. And the research shows that these hidden hazards, they are more complicated for the drivers, for all drivers to deal with. The procedure of the experiment was as follows. The participant came in the lab, they got written instructions, and they did the first introduction drive to get used to the simulator, to know the controls of it. Then afterwards, they fill in the first questionnaire. The eye tracker was calibrated, and they could do the driving session. And there were 3 different driving sessions, different questionnaires, what they fill in. So how did I define the hazard response? So the driving speed was measured 50 meters before the potential hazard. And in every 10 meters, the average speed was calculated and compared to the next interval. And the first interval was identified where the driving speed decreased. And based on that, the drivers, participants in each condition were placed in groups. One is if they responded in a good time before the critical point, then they were placed in this response in time group. If they didn't respond at all, they didn't increase the speed during those all 50 meters, then it was a no response group. And if they responded to the potential hazard, but they did it after the critical point, which was after it's, when it becomes too late to actually do something, if the hazard materialized, then they were placed in this late response group. However, there were only two participants fell in this group, so that was excluded from the further analysis, even though it would be interesting to see who were those people and why did they do what they did. And I have to say that also the hazard, the pedestrian, was coming out, so actually drivers had to respond to it. So that was a situation that actually if the pedestrian kept it running, they had to actually decrease the speed. And I looked at the hazard fixations. I used the measures which commonly shows the difference between more experienced and less experienced drivers, and looked at the general fixations. So I looked at how widely do they look around, what is the fixation horizontal angle, and what is the length of the fixations. When looking at more in the concrete, so how did they fixate on this potential hazard, I was interested to see how fast do they fixate on it, for how long do they fix on it, how often do they fixate on it, and how much attention do they devote to the potential hazard. So now we can move on to the results. And as I said previously, the drivers, based on their response, they were divided in 2 groups, in no response group and response group. And you could say that the drivers in the no response group had a lower hazard perception skills than the drivers who responded in time, because it was a situation where they actually had to respond. It was in a visible situation. However, in the hidden situation, there was no difference between drivers who responded and didn't respond and responded in time. And I have to say that also the drivers, where's the button? Okay, sorry. Yeah. Whatever, the drivers who didn't respond to the visible hazard also didn't respond to the hidden hazard. So it shows that this is the group of the drivers with the lowest hazard perception skill. Yeah. To obtain the more precise profile of the driver in both groups of this higher and lower hazard perception skills, the hazard fixations were analyzed. In general, everyone fixated on the potential hazard at least once. So that means that drivers who didn't respond to it, it wasn't because they didn't notice it. They noticed it, but just deliberately chose not to respond to it, or didn't see it as a hazard. And there were no differences in general eye movements among all drivers. So the drivers with the higher hazard perception skills, there's the drivers who responded to this potential situation. They fixated more times, and also they kept an eye on a pedestrian after it stopped running. So they're fixating continuously on a pedestrian, showing they were paying more attention and being more aware, okay, what happens if the pedestrian keeps on running? And additionally, they also fixated on a speedometer at least once, or even more than once times, saying that they were considering their speed more than the drivers from the lower hazard perception group. And drivers from lower hazard perception group, the drivers who didn't respond to the hazard, they were closer to the pedestrian when they first fixated on it, leaving then less time for them to respond. They also dwelled longer on this potential hazard, showing that they had longer process time, the longer processing to actually acknowledge the potential hazard. And after the pedestrian has stopped running, they didn't fixate on it. They kind of swept over the view and kept on driving, so not really paying too much attention to it. I have to go back. So the overall results show that actually the hazard fixations, and these are the results who are actually also showed in the literature, that these hazard fixations, they distinguish between the more experienced and less experienced drivers. So that's why we could say that the fixation results, they confirm our division of the groups based on the simulator responses. If you move further to the responses and fixations of the child and adult pedestrians, then I could see that the results show that all drivers, they were actually having the higher driving speed when they were passing the child pedestrian than the adult pedestrian. The difference was significant in a visible condition and not in a hidden. However, they adjusted their lateral position further away. Here you can see that this means that this is a pedestrian and this is where they drive. So they were driving a bit further away from the pedestrian when it was a child than when it was an adult. And hazard responses showed that drivers also had a lower hazard perception skills of the child pedestrians because they were responding. Where is this? This means it's a child hidden, adult visible, child visible, adult hidden. The drivers were not responding as often to the child pedestrian than to the adult pedestrian. And again, this difference was significant in the visible condition. So it might be the case that the drivers didn't adjust their speed and didn't respond to the pedestrians, thus taking account the limitations of the child pedestrians and the safety problems that it can cause. When we look at the fixations on the pedestrian, then again, number of fixations were more in the adult pedestrian, making me think that they were considering them more. However, at the time, the first fixations were not different between when they saw the adult or child pedestrian. And this finding might confirm that the driver is actually, since they saw both pedestrians at the same time, they were aware of them. And then they didn't see the necessity to adjust for the limitations of the child pedestrian. But for this, my conclusion after further studies should be carried out to confirm this, my conclusion. And also length of first fixation was longer on a child pedestrian, saying that maybe there was longer processing needed for them to acknowledge them as a potential hazards. So now we can move on to the subjective and objective skills. An accurate self-assessment of one's hazard perception skills is important because it gives the basis for the relevant behavior adjustments in a critical situations. And drivers who overestimate their driving skills, they might be more prone to be involved in risky situations because just they have the feeling that they can handle them. And what I wanted to know is just to see if the self-assessed hazard perception skills are in line to the hazard perception skills what I measure in a simulator and with an eye tracker. For that reason, to get the subjective measures, I used standardized questionnaires, such as driving skill questionnaire developed by McKenna, which asks questions about drivers' general driving skills, overall driving skills, and driving skills in specific situations. And also hazard perception skill questionnaire was used where the drivers were asked to compare themselves with the average driver, how they think how their hazard perception skills are. And also brief sensation seeking scale was used to see if the drivers who are more sensation seeking, if it has an influence on the hazard perception skills. Yeah, the results on this shows that drivers that the drivers, we compared again the drivers with the lower hazard perception skills and higher perception skills, and to see how they responded, what kind of self-assessment they had. And then it shows that the drivers with a higher perception skills measured in a simulator, they also thought themselves that they had higher driving skills overall in specific situations, and also higher hazard perception skills. So the results suggest that it could be used as an indicator. This questionnaire can be used as an indicator of the objective hazard perception skills in the driver. However, this was significant only in the visible hazards. And the sensation seeking also was higher for drivers who responded in time, for those who had a higher hazard perception skill. So the results suggest that the drivers who are more sensation seeking, that doesn't have a negative effect of the hazard perception skills. To wrap up the first study, so the two subgroups of young drivers were identified based on their hazard responses, hazard fixations, and self-assessment. And also the results show that young drivers overall, they needed training to train their more advanced hazard perception skills in hidden situations. And it might be the case that drivers are not aware of the risks associated with the child pedestrians, and there's need for awareness of the speed adjustments near these potential street crossing situations, especially involving child. And subjective measures of the hazard perception and driving skills can be used as a proxy for the objective driving skills, however, only for visible hazards. And as I said, specific hazard perception training might be needed for young drivers in the hazards specifically which requires more advanced hazard perception skills. So now we can move to the study 2 after the interval. So the aim of the second study was to improve the hazard perception skills of the young drivers in pedestrian-related potential hazard situations. Hazard perception training is not new per se. In recent decades, there are studies which shows that the hazard perception skills can be increased off the road, and it has a nice impact on developing hazard perception skills. But usually it's done with computer-based methods and video-based methods by training people to detect the hazards and notice them, but not to respond to the hazards. And there hasn't been training specifically made to improve the hazard perception skills of young drivers in pedestrian-related situations. These pedestrian-related situations have been included in all other trainings, but pedestrians, they create different risks in traffic than other vehicles. For example, they're smaller, they're harder to notice, therefore. They also approach mostly from the sides. They're not in front, as it is with the cars, so drivers have to widen their angle to notice them. And also that they're not physically restricted to cross the street wherever they want, so they don't have to wait necessarily for the intersection or the crossing. They can just really cross wherever. So that creates different situations than it is with the other vehicles, than it is with the vehicles. Humans learn the best by committing errors rather than getting instructions in the error avoidance setting. Therefore, the error learning method has been used in driving simulator studies. Driving simulator is a perfect tool for that, not only because drivers can actively be engaged, control and influence the setting of the environment in real time, but also, of course, it provides a safe setting for actually committing the errors and learning from them. And some studies, they show the improvements in hazard perception using this error learning method, but it's only be tested to the actual hazards and not potential hazards, which are more difficult. And also, another study shows that it improves the hazard fixation, but that nothing doesn't show how it could improve the hazard response. So so the training, what I allowed, consists of 3 parts. And the first part was that drivers went through the drive where there were several potential and actual hazards. So the drivers, if they didn't notice the hazard well in advance, it might have led to the accident. So if that was the case, then the participant had to do the driving again and again until there were no accidents. After that, they saw the video where the instructor was explaining them. It was a commentary video where prepared together with the driving instructor, where he explained what kind of driving speed to maintain and where to look to detect and how to avoid potential hazards. This kind of instruction is important as well, because if the drivers just commit the errors, they might start to blame the environment and other road users for their mistakes. So that's why there's more implicit explanation for how to avoid these errors is needed. And afterwards, drivers saw the replay of their last training drive. So they see it together with the speed profile as well, to see what kind of speed they actually maintained, to compare their behavior to the experts' suggested behavior, so they could get the indirect feedback of how did they do and how can they improve the style. The procedure of the experiment was that there were 60 participants. They were randomly assigned to the training and control group. First, they came in, again, as it was before. They had an introduction drive. They fill in the pre-questionnaires, which was driving skill and hazard perception skill questionnaire. And they drive through the base drive, which consisted of several potential hazards. After that, the training group got the training, all 3 parts. And after that, test drive came. And the post-questionnaires were filled out. So the results showed that when you look at the hazard response, they showed limited improvements for the trained group in their hazard perception, in their hazard response. They slowed down in 2 out of 7 situations. However, these situations were hidden, so they were the ones which requires higher hazard perception skills. And then we looked at hazard fixations. Then the the trained group, they fixated more times on the hazard. And they did it, and they fixated more times, and also they had a wider angle of the fixations in 4 out of 7 situations. And 3 of those situations were hidden, and 1 was visible. And here you can see the visualization of the eye fixations. So the training group, they were looking wider on the side of the streets near this zebra crossing, where there's a car parked, and searching for potential hazards if there could be the pedestrian which comes out. And yeah, look at the results of self-assessment of their skills. Then actually the results showed that the drivers, after the training, they thought of their skills being lower than before the training. And this is nice that could be that the exposure to the errors and actually letting them commit errors made them more aware of the limitation of their skills and possible flaws in their hazard perception. So the implications of the study. So the method showed some limited improvements in the hazard perception skills of the drivers. So it could be used as an initial step towards the development of the relevant training module for having this kind of hazard perception skill training in pedestrian-related situations involved in a driver's training. And exposure to the critical situations might make people more aware of their actual skills and the limitations of them. And but as it is with all the simulator studies, it's hard to know how they translate to the road, so that's why the follow-up on-road study is necessary. And also, in this study, it would be nice to see how long the training effect actually lasts. And yeah, so that's why it would be nice to do some follow-up studies on the road, actually. To conclude everything about my project. So this project identified and examined 2 subgroups of young drivers based on their hazard response, hazard fixations, and self-assessment of their skills. And that confirmed the measures in the simulator. So the finding contributed in a better understanding of the pedestrian-related situations from the driver's perspective. And the need was identified for the training for the young drivers, focusing on the hazards, which actually requires higher hazard perception skills, more advanced hazard perception skills, and the need for raised awareness on the speed reduction in potential street crossing situations involving child pedestrians will be necessary. and short intervention. Since the short intervention showed some benefits, so after the certain adjustments, it can be considered to include as a separate module in a driver training. And implementation of videos is easy, and due to the rapid development of the technology, the simulators are becoming more available and cheap. So it could be considered to have this training in a simulator, not in all driving schools, but in centralized locations, as it is in a advanced slippery track. Thank you, everyone. That's it.
Thank you, Liva. You made it easy for me so far. You kept your presentation within the time limit, so thank you. And now it's time for a short break, and then after the break, we will start with the questions, starting with the committee. And I think we should, so we start 1:45. Mm-hmm. And again, if anybody from the audience has questions, please inform me during the break. Thank you.